Okay, this is part 2 of the review of circular functions from year 11. So let's just go through defining circular functions, the sine, cosine, and the tangent function. All right, so how would I find x and y in this diagram? Well, let's grab this triangle here that's been made. We've got theta, we've got y, we've got x, and we've got 1. Okay, so now let's use some basic year 9 trig here to get these x and y values. So let's do x first. That's the adjacent and the hypotenuse, which is the cosine. So cosine theta equals a on h, or x over 1, which is equal to x. So x is cosine. What is y? Well, it's the opposite over the hypotenuse, and over h is sine. So that's opposite, which is y over 1, which is y. So this one here, the y value can be obtained by doing sine. Okay, so the way to remember that, girls, is I think about it, cosine theta and sine theta in alphabetical order will appear like that. Cosine would be first, sine would be second. And then the values that I'm talking about, either x or y, if I put them in alphabetical order, will be x first, followed by y second. So cosine is x, sine is y. It's convenient that it works like that. What about tangent? Okay, so an important trig identity is the fact that tan theta equals sine on cos. Okay, and if you understand this identity and how it's derived, you do have a good understanding of circular functions. So if you imagine this line here, A, B drawn, that's what we call the tangent. Okay, the tangent, not a tangent, but the tangent. So the tangent. Okay. Now the value of tan is the intersection of a line drawn from the origin, 0, 0. So we draw that line, and the value of it will be where it hits this line here. That's the value of the tangent. Okay. So here it's roughly 0.7 if this is positive 1. Okay. So how to know what it is then? Well, I've got this big triangle here, and what I know is this angle here will be the same using this side here and this side here and this side here as it would be for this smaller triangle, this one here. Okay, and so if I know that that's x and that's y, and I know that x is given by cosine, and I know that sine is given by y, then the tangent is going to be the opposite over the adjacent, that over that, okay? So tan theta is the opposite over the adjacent, y over x, or sine theta over cosine theta, which is what we had there. All right, so let's look at some exact values. All right, so these ones here are ones that are key points on the unit circle, okay? So here is 0, here is pi on 2, here is pi, and here is 3 pi on 2. So these are the ones that we're referring to here. And what we want is the sine value, the cosine value, and the tan value. So let's start at 0 and note that the sine value is the value of y at this point. Well, have a look at where it hits the y-axis at 0, i.e. the sine of 0 is 0. Okay, let's look at the cosine value at 0. The cosine value is the x value it hits, which is positive 1. Here's 1, here's 0, and here's negative 1. Now the tangent, well, let's imagine a tangent drawn there, and imagine a line drawn from 0, 0 through this point here would hit the tangent at 0. Let's head up to pi on 2. Okay, so at pi on 2, what I know here is that the sine value is where it hits the y-axis, and it hits the y-axis at 1. Where does it hit the x-axis? From that point, go down, and you note that the x-axis is hit at 0. And the tangent, well, this line here, or a line drawn from here going up through this point here, will run parallel to the tangent, i.e. it's never going to hit it. So what we say is the gradient here is undefined, not the gradient, the value of the tangent is undefined at pi on 2. All right, let's go over to pi. All right, so the sine dips back down to 0 at that point. The cosine is 1 as well, but it's on the negative side here. So the cosine is negative 1, And the tangent, well, a line drawn through there and through the tangent will be back to 0, 3 pi on 2. Well, 3 pi on 2 is going to give us a sine value of 1 in the negative side, so that's going to be -1. Hits the x-axis at 0 for cosine, and the tangent again runs, or this line here will run parallel to the tangent, so it will be undefined. At 2 pi, we're back to where we started. So all of these values will again be repeated, which explains the cyclical nature of the graphs of trig functions. They go like that, then they just repeat and repeat and repeat. All right, so let's evaluate some of these exact values. Okay, so sine of 3 pi on 2, well, we're here at 3 pi on 2, and our sine value here is going to be -1. What about -3 pi on 2? So we're starting there and we're going in a clockwise direction. We'll end up here. So the sine is the y value, that is 1 at that point. 5 pi on 2. So here is 4 pi on 2, or 2 pi. So 5 pi on 2 will be 1/4 more around the unit circle. So this is the same as the cosine of pi on 2. So one full loop and an extra pi on 2 will be 5 pi on 2, where after the cosine, which is the x value, it's going to be 0. Cosine of -pi on 2 means start here, but head over in this direction here. So that's the same as the cosine of 3 pi on 2, and the cosine there is also 0. So it hits the x-axis at 0. The x value there will be 0. All right, let's do this one, 23 pi on 2. So that's the same as if I put 2 into that, it's going to be even, well, let's do it. So 2 goes into 23 11 times. So cosine 11 and 11.5 pi is going to be what we're after. So I've just converted that to a mixed fraction. All right, now why did I do that? Well, what I'm noting here is that this is like 1 pi. This is 2 pi, this is 3 pi, this is 4 pi. So on this side here, I call this even pi. When I've got even pi, I'll end up at 0. When I've got odd pi, I'll end up here. Okay, so 11 pi is going to be end up with me being there, and we want to go half a pi more than 11, which means we're going to end up there. So this is exactly the same as cosine of 3 pi on 2, which will be exactly the same as these other instances here. The cosine value at that point is 0. 55 pi on 2. Well, we want to put 2 into 55, and I know that that's going to go in 2 into 55. Well, I don't know that it's going to go in. 2 into 55 goes 2, 1 remainder, 7. So it's going to go 27. So we're going to say that equals sine 27.5 pi. So this is what I call odd pi. So we're starting there, going half more, and we want the sine value at that point. So this is exactly the same as saying the sine of 3 pi on 2, which is -1, 55 pi. So here's pi, 2 pi, 3 pi, blah, 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 all the way to 55, or odd pi. That means that that's the same as the tan of pi, and we know that the tangent drawn through there will run back through the tangent there, which is 0. Okay, last one, tan of that is going to be 7.5 pi. We're at odd pi and half a pi more. That's the tan of 3 pi on 2, and the tangent runs, or this line here runs parallel to the tangent, so we're going to say that this is undefined. All right, what about other exact values? Well, there's a few that will certainly be asked, okay, and let's develop some of them. So I don't memorize the table, wouldn't have a clue what the table looks like, but we've got these two triangles that you can draw, and these two triangles will allow you to generate all of your exact values. So this one here, I call this the 2, 2, 2 equilateral. Equilateral. And this one here, I call this the I don't even know how to spell isosceles. I think it's with a C. Isosceles right. Okay. Now, 2, 2, 2, isosceles right means this one's 1 and this one is 1. Using Pythagoras' theorem on this, I know that this side here, and you can do it for yourself, I know that that will come out as root 2. Now, because this as if it increases by 1, or as x increases by 1, the y values go up by 1, that means that it goes on an angle of 45 degrees, or in radians, pi on 4. Let's go over to this one here. So what I'm going to do is split this equilateral into two parts. That's 2. This length here is going to be 1. And using Pythagoras' theorem, that's going to be root 3. What are my angles? Well, that's 60 because it's equilateral, or pi on 3. This one here was 60, it's been halved, so it's now 30, or pi on 6, and that's of course 90. All right, so with these two triangles now, I can generate all of my exact values. So the first one I'm going to do is the sine of pi on 6. Here's pi on 6, we want the opposite over the adjacent, that's a half. Okay, let's do the sine of pi on 4. Pi on 4 is here, opposite over adjacent, 1 over root 2, or if rationalised, is root 2 on 2. All right, the sine of pi on 3. Pi on 3 is here, opposite over adjacent, it's going to be root 3 on 2. Right, let's go to cosine. Right, now what I know with cosine is these two flip and this stays the same, okay? So cosine of pi on 6, here's pi on 6, it's going to be the opposite over, the adjacent over the hypotenuse, which is root 3 on 2. So that one goes to there. This one will go to here, but let's do it in a sec. We've got pi on 4 adjacent over hypotenuse, which is 1 over root 2, or root 2 over 2. This last one here is going to be pi on 3. On 3 is there, adjacent over hypotenuse is a half. Okay, tan of theta, where theta is pi on 6. So pi on 6 is here, so it's 1 over root 3. This one here is going to be 1 over 1, which is 1. This one here, we go to this one, which is the opposite over the adjacent, which is root 3 over 1, which is simply root 3. Just note that this one will rationalise to root 3 on 3. Okay, so let's do it. 5 pi on 4. So the basic way of doing these is I kind of first of all look at where I am on the unit circle, what trig function, i.e. I'm looking for either x or y, and then I go to equivalent, no I don't do that, I go neg or pos, okay, and finally equivalent first quad. All right, so these are the basic questions I ask myself each time I do an exact value calculation. So I need a pretty dodgy looking unit circle to do these questions. And we've got 5 pi on 4. Okay, so this will be pi or 4 pi on 4, and this is 5 pi on 4. So that's where I am. Okay, so that's the first question answered. What trig function? So I'm cosine, this is x. Okay, so I'm x. It's negative or positive? I know it's negative. All right, now the next thing I need to know is whether it's the equivalent first quadrant angles. So I go to the first quadrant, and that's going to be it. So it's going to be pi on 4 is exactly the same as this one here. So what I'm going to do is work out what the cosine of pi on 4 is from the first quadrant, which will give me this value here, drop a negative out the front of it, and it gives me this one here. So I know that cosine of pi on 4 is 1 on root 2, so this is going to be negative 1 on root 2. This one here, we're going to do the sine of 11 pi on 6, which in the unit circle or on the unit circle, here is 12 pi on 6 or 2 pi. It's going to be pi on 6 back from that. So that's where I am. What trig function am I? I'm sine, so I want this value here. Okay, it's negative or positive, it's going to be negative, so I write down a negative. Then what I do is I do the equivalent first quadrant angle, which is going to be the sine of pi on 6 in the first quadrant. Now pi on 6 I know is a half, so this is going to be negative a half. Cosine of 200 pi on 3. All right, so that's going to be, let's put 3 into 200, and that goes, what, 6, 2, 6, 66 and 2/3. So that's the cosine of 66 and 2/3 pi. All right, so how do I do this one then with a unit circle? Well, what I'm going to note is this is 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 66 pi. So we're going to go 2/3 more. Okay, there I am on the unit circle. I'm cosine, so I'm x. I'm negative there. What's the equivalent first quadrant angle? Well, it's going to be pi on 3. Whoops, negative cosine pi on 3. Okay, so the cosine of pi on 3 is, mental blank here, negative, that's, I think that's a half. Let's go to the triangle. Cosine of pi on 3 is adjacent over hypotenuse, negative a half. All right, this last one here is a tangent. So that is the tan of 26 over 3 pi. That's the tan of 3 goes into 26. I've got 8 and 2/3 pi. Right, 8 3s are 24, 2 left over. Yeah, that looks good. All right, let's draw my unit circle. 2 pi, 4 pi, 6 pi, 8 pi, 2/3 more. The same point as here. So that's going to be through there and hit the tangent down here. So it's going to be negative. Equivalent first quadrant is this one here. So negative tan of pi on 3. Okay, so the tan of pi on 3 is going to be root 3. There we go. All right, last couple of questions I think for this. All right, so I know something about this. They're telling me that the sine of x is equal to 0.6. So the sine of a particular angle here, the sine of x, is 0.6. So that's its value there. So what we want to do then is go, what is pi? Take away this. So we start at pi, we go all the way across to here, and it goes, whoa, 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 back up the truck. Go back this amount. So go back to here, all right? So that's going to be how far we go back. That means that we want this sine value here, which will be exactly the same as the sine of x, okay? Because over this side, we hit this y value. Over this side, we hit this y value. And I know the sine of x is 0.6, so I know that one. Right, pi plus x. So we're going to go down here. So this is where I am. All right, so this is the value I want, which is exactly the same as this value with a negative sign dropped on it. So this is equal to the negative sine of x, which is negative 0.6. This one here starts us at 2 pi and it goes back up to negative x. So that's how far we're going to back up there, which means we want this value here. That's going to be the negative sine of x again, which is negative 0.6. Negative x means start here and go back x, which will be exactly the same as this one here, negative 0.6. All right, down to this one here, we've got the cosine of x is 0.8. So let's just draw that. Is that value there, 0.8 rather, not 6. Okay, so, and that is x there. So this one wants us to start at 180, which is here, and track back x. So that's it there. And we want the cosine, which is this value here. So what it's going to be is 0.8 with a negative out the front. So this is negative cosine of x, or negative 0.8. 180 is here. We're going to go forward x, which is going to be the negative, and it's going to be the cosine of x, which is negative 0.8. So 360, go back to there, okay, which means we're going to hit the positive version of that. So this is just the cosine of x, which is 0.8. This one says go back x, which takes us there, which hits the positive version of it. It's just the cosine of x again, which is 0.8. All right, so there is your review of exact values and symmetry properties.